Everybody, I think we're going to get started here. Thanks for coming by. Pretty exciting summit so far. I know seen some pretty cool stuff, especially Red Hat application, the mobility platform, and a lot of stuff around OpenShift has been pretty interesting as well. So thanks for coming by our talk. Welcome to Securing Your PaaS with SecurePaaS. I'm Tony Stafford, and this is Derrick to my right. A little bit, real quick intro about the company we work for. We're both representatives from Shadowsoft. We're a partner of Red Hat's. We do consulting services, procurement, implementation, managed services, and then also R&D. And some of the R&D work that we've been doing, you're going to get a chance to see today. Get a little bit of a line card there on the side. A little bit about me, 15 years of cybersecurity expertise, mostly in the public sector. Worked as a cybersecurity analyst for a 3-letter agency for several years, and then ended up as the emerging technologies lead, specifically for the U.S. Navy. So I was advising the DON CIO and the DoD CIO's office on new technology trends, technical maturity, as well as advising on adoption and value in the technology spaces. Derrick is a lead developer, was the lead for the Navy Tactical Cloud, which is a big data analytics system that was deployed on a couple of pilot ships, and has been an application security developer along with a master's degree in cybersecurity. All right, so let's talk a little bit about our cloud computing future. A lot of people have been talking about the cloud. I'm sure it's almost become meaningless in a weird way, right? The term cloud, because it's become so normalized. But the way that I see it, it's going to, basically increase resource sprawl. You have your private data centers that are hopefully going to be infrastructure and platform service enabled. You're going to have your public cloud compute, Amazon, Azure, kind of pick your flavor. So how do you control access across a global enterprise? How do you control the applications that are being deployed within these cloud computing environments? It's about application and workload portability, elasticity. So things can be deployed kind of build once, deploy anywhere model. Doesn't matter where it's running. Ultimately, your customers don't care where it's running, right? The people that are actually using the applications, that are consuming the resources, don't ultimately care where it's hosted. They don't care whether it's hosted on OpenStack or is using OpenShift ultimately. What they care about is accessibility to their data and that the applications are available. So how do we secure applications that could be running potentially anywhere? And then as data and application availability becomes more and more prevalent, traditional security mechanisms are not going to solve any problems, because applications and web services are going to turn into security mechanisms. Traditional firewall is not going to help when your applications are ultimately opened on the internet so that people can access them from anywhere. So with that in mind, how are we going to secure those applications and web services that are ultimately going to protect the data that your users need access to? Now let's compound on top of that code development and how it's changed over the course of time. So back when computing started, it wasn't actually a field of study. It was mathematics. People were taking a degree in mathematics and were ultimately trying to learn how to construct automation systems. And they were built as one-offs. They would build a large computer that would perform one calculation. Eventually, it turned into programmability. Programming languages started to emerge. Over the course of time, universities started opening up things that were more computer-focused. So people with master's degrees in electrical engineering became kind of the computer operators of the time. Eventually, it dropped down to a bachelor's degree level, where people could go and get a bachelor's in computer science or in computer engineering. And then during my time in high school, we could take programming classes. By the 1990s, computing and programming had turned into an actual high school curriculum. And now we've got middle schoolers programming, and even younger. I was on the Apple App Store a couple weeks ago, and they were highlighting the top 20 developers under the age of 20. They had a whole section of the App Store dedicated to them. So we've seen how code development has basically dropped down to a very, very low level of required expertise to perform. At the same time, we've gone through an evolution in computing itself. Mainframe computing to client-server to web-based systems, web-based system to SOA, and now we're currently in the microservices enablement, mobility, and cloud era. So the interesting thing about that trend is computer systems are getting more and more connected over the course of time, while the requirements in code development are actually descending over the course of time. So we've gone from, this, where it took a team of people to, run and build systems, down to this, where you've got a small child programming a robotic crocodile on a little leapfrog computer. Now, on top of that, we've got the rise of microservices, right? So why are people so interested in this? They're modular, they're reusable, they're scalable. But there's challenges that exist with these microservices as well, such as consistent platform deployments, universal data interfaces, and pervasive security governance. So as people basically build these microservices, and now you want to orchestrate them in various new and interesting ways, there's no uniform way to kind of manage all these pieces all together. Now, this diagram is Docker growth over the course of 2014. Between Q1 and Q4 of 2014, there was over a 500x increase in the amount of Docker downloads over the course of that time. I haven't seen that type of growth in a long, long time, but what it says to me is that microservices is here to stay. This is not just a flash in the pan, buzzword-worthy thing. This is a reality that we're going to live with for quite some time. And so what does this tell us about the current security landscape, which is why we're here? So it tells us that the education requirements for development over the course of time have descended. But because systems have become increasingly connected and complex, the requirements for security understanding has increased exponentially over the course of time as well. And so now we've got a knowledge delta of middle schoolers or people who are under 20 years old building applications based on high school education and have no understanding of the cybersecurity underpinnings that are required to actually secure your data in your applications. So there's a knowledge delta there. As systems become more complex, cybersecurity additionally becomes more complex. Now, I've got another factor to consider as well, which is hacking or breaking into these systems is very different today than it was 10, 15, 20 years ago. Used to be a very complex task. Used to be people dumpster diving, trying to dig through garbage cans so that they could get access to manuals about hardware that you were potentially running on so that they could experiment and try to break into your systems. Also at the time, hackers were not interested in financial gain. They were interested in learning. They were interested in understanding how your system worked, and they were interested in basically having a good time by messing around with what you were doing. Nowadays, because information is so accessible, there's a financial gain that can be made through hacking systems, and there's a financial gain to be made in building automation and tools that makes that hacking even easier. So nowadays, there's tools out there. I can hack a Wi-Fi network from my phone. I don't need to understand security all that well either in order to hack into a system. But those aren't the only threats that we're concerned with, right? Hackers are really ultimately only one piece of your security risk, right? You've got corporate espionage, which is on the rise right now. Intellectual property, especially in the digital format, is very, very portable. It's very, very easy to move around, and it's very, very lucrative to sell that information. Additionally, you've got rogue employees, people who are disgruntled, people who don't like your company, don't like your policies, don't like the decisions that you're making, and therefore are going to expose information about you and your company to the public for the virtue of basically protesting what you're doing. And then you have straight human error, which probably accounts for a majority of the security vulnerabilities out there. All humans are prone to error, so humans being responsible or solely responsible for your security system is in and of itself a challenge. Everyone's a potential attacker, whether they intend it or not. Human error is just a passive attack, ultimately, on your system. Any and all of your applications and services might be vulnerable to attack. Most organizations don't necessarily know whether their system is vulnerable or not because they're receiving their applications from multiple different places. You might have an internal development team, a small team that's building things specifically for your enterprise. You might be outsourcing some of your development to other organizations to build things on your behalf, and then you might be purchasing software off the shelf. And you are injecting all of these things into your enterprise, and you don't have 100% confidence in the security mechanisms that a third party is putting into place, or that an outsourced person is putting into place, or the human error that can occur. I highly encourage you to take a look at the OWASP Top 10 if you're not familiar with it. It's basically your online security flaws. It's things that are most commonly used to break into enterprise and corporations through web applications. And this ultimately puts you and your customers' data at risk. So let's talk about abstraction and automation really quickly. So we know that we need platform management. We know we need the ability to build something once and deploy it anywhere in an agnostic way. That's really true if you want to take advantage of the platform as a service efficiencies that can be gained. Without that in place, you're not going to be able to efficiently take advantage of your resources that you're exposing through your infrastructure as a service. You need data interface standards because your data also is going to live anywhere. Most organizations are not homogeneous, right? They've got different types of data sources all over the place. You might have MySQL or Postgres or some other SQL systems. You might have no SQL systems running. You might have some traditional Oracle-type databases working. So how do you interface with those things? How do you loosely couple applications and loosely couple the data to those applications in order to create new orchestrations and new interesting business value? And that's going to be done through something like JBoss Datavert. At the same time, there's a third factor that we really consider, which is a security standard framework, a way to inject and manage security universally for your applications. Because as you're absorbing all this code, all these different applications and services from different organizations, you don't have a way to really govern those pieces, not without decomposing and reconstructing all the code that's being deployed within your environment. And for that, we've built a solution called SecurePaaS, and that's what we're really here to talk about today. So what is it? It's a management system. It's a management UI that allows for you to construct and author policies. It's auto-integrating, meaning that it can do inline code injection into Java applications. It's authentication, basically authenticating requests down to a method level within your applications. And it's auditing. So we audit every transaction that takes place within your system without the need to instrument that yourself, down to a DSKID 6.3 level of compliance. Now, for people that don't work in the public sector, that doesn't mean a whole lot, but DSKID 6.3 is essentially the intelligence community's requirements for data retention and handling for auditing information so that you can actually prosecute people should something actually occur, which means that our auditing system should allow for a prosecutable level of data if it's handled properly after an event occurs. What are the components? What makes this up? We've got what we call UVAP, but ultimately what it is it's a system that ties all of your microservices together. So as you compose these different applications, and if you're using Docker, you're probably creating a lot of stateless applications because they're designed to be deployed and destroyed very quickly and with rapid speed. So how do you tie a user session across that rapidly deployable and destroyed space? How do you tie in all the authorization methods needed in order to know that whoever's accessing the data at the end of that workflow ultimately has the authority to see what you're actually providing them? It's automatic code injection. So one of the challenges that we saw in this space is that there are software developers out there, and software developers are very, very talented at what they do, building applications, building code. But on the other hand, you've got security personnel, and security personnel tend to be more policy-driven. So generally speaking, developers are not necessarily great at security, and security guys are not necessarily great developers. So this creates this strange push and pull within organizations, where security people are saying, well, you can't do that. And the developer's like, well, if you don't like how I'm doing it, then you tell me how to do it. And the security guy goes, well, I don't know exactly how you should do it because I'm not the developer, but I can tell you what not to do. So we decided that there needed to be a way that a person who builds policies for a living can ultimately inject secure code into applications that are being deployed. And that's what that function provides. Cross-domain auditing mechanisms means that as you deploy these applications, no matter where they're deployed, whether it's in the public cloud, hybrid cloud, private cloud, it doesn't matter. We're going to be able to audit across the entire domain of your enterprise. The artifact resolution service is actually an interesting piece of the puzzle. So we use SAML 2.0 specifications as our tokening system, if you will. And the challenge here was we didn't want the user to necessarily have access to that token. Now, the rationale behind that is because once a person has ownership of the token, it's an XML artifact. It can be modified. It can be changed. So the artifact resolution service purpose is to hold those keys in escrow on behalf of your user. So when a user asks for something, they're not receiving the actual artifact themselves. It's actually held on their behalf by the system. What this means is that the user, or somebody in between the system and the user, can no longer take that token and use it, abuse it, modify it, change it, and exploit a weakness in your system. Policy enforcement and decisioning points, we use these throughout our system as a way of making intelligent decisions about who can access what, at what time, from what location, across the board, and then a full-featured management UI. So all of this is uniform. It's all unified through a single pane of glass. But what's interesting about our particular solution is it's built in such a way that we can actually create separation of duties. So you might have somebody that can build policies, but might not be able to apply those policies. Or you might have somebody who can look at audit records, but can't do anything else. Their whole job in life is to look at those audit records and make sure that systems aren't being abused. And so we've created it in such a way that the management UI can be itself locked down to allow for things like two-person integrity to take place. So what does it look like in action? Well, we're agnostic as far as application hosts are concerned. So whether you're using JBoss or Tomcat, Jetty, J2E compliant container, as long as it's running Java, we can handle it. And the whole concept here is you've probably got a bunch of different application servers running. You've probably got them spread out across your enterprise, a mixture of things that's probably not uniform. And then you've got applications and services that are going to be cross-chattering between these different application servers. So how do you tie security for all these different disparate systems into one another? So what we do is we apply our agent, and basically we refer to it as a CAP, or a context-aware policy enforcement point. And the purpose of the CAP is to introspect what's held within those Java containers, and then be able to apply security mechanisms in a fine-grained fashion. So as you apply these things, it now will tie these systems together. So you now have a security fabric that's going to tie your different applications hosts together, as well as tie your services and applications together as well. From an architectural perspective, it kind of looks like this. So you'll see our application host over on, I guess that would be your left-hand side. And then you've got our system sitting over on the right. Our system consists of a master policy service, which basically pushes our policy changes out to the SecurePaaS agent. We've got our identity provider, along with our artifact resolution service, and our auditing services, which are auditing all the transactions that take place within your servers. Also, additionally, we've got our management console, which consists of a CAP update service, which is our context, once again, our context-aware policy enforcement point, and then the management dashboard itself. You'll notice on the back end, we've got a Postgres and an LDAP. We can interface with just about any LDAP interface you've got. So whether you've got an RHDS Active Directory, whatever it might be. If it's got an exposed LDAP endpoint, we can inherit those things. And then as far as the Postgres is concerned, that's primarily for our auditing system. So if you wanted to offload your audits into a pre-existing auditing system, if you're using Splunk or ArcSight or what is that? syslog-ng, we can offload that into those things as well. What's the purpose and benefits of these things? Well, it reduces time and effort, which is ultimately what we all want out of automation. So what do we reduce time and effort on? Creating and applying users' roles and attributes. This is normally a heavy lifting activity from what I've experienced in my career. Creating and applying security policies to resources. This has been a very, very large challenge for enterprise for a long, long time. How do you universally apply security policies across entire domain sets? And how do you do it in a way that doesn't create new security vulnerabilities, doesn't create new security problems? How do you avoid that human error that's intrinsically associated with something as nuanced as creating security policies for resources? Security framework, systems integration, and training. So when you see our technical demonstration, it'll be very obvious, hopefully, to you. But ultimately, we can train somebody to use this system in 15 minutes from a basic level. It's really not very complex. It does a lot of complex things on the underpinnings. There's a ton of automation, a ton of automatic code creation and injection, but ultimately from a user's perspective, it's very, very simple to use. No code modification required. So this was an interesting piece, right, which was, okay, if you want to modify the security of an application, traditionally you've got to have a developer go in, build a new build of your application, apply the changes that you want to have done, and then resubmit that code back to be reconstructed. With us, we can actually automatically provision code at runtime. So there's no need to crack open an IDE. There's no need to send it back to the development floor. We can apply those things after the fact, which means that ultimately you're governing your security system without developers needing to know what that governance looks like. And then we kind of mentioned this before, but we are vendor agnostic. We're J2EE compliant. Now, as far as the demonstration today, this is what our demo architecture looks like. So we've got a couple of OpenShift v3 nodes. Everything's been Dockerized, and we've got 2 application servers that you see here, JBoss Container 1 and 2. Now, one of them has our agent installed, and one of them doesn't. And that was done so that we can show basically the differentiation between what a vanilla version would look like and one with our system installed. And then we've also got these containers in another services node that basically shows our Cupid connector, RHDS, Postgres, as well as the actual SecurePaaS components itself. Now, real quickly, before we get to the demonstration, if you'd like to follow us on Twitter, please do. If you'd like to email us, that's great. We've got a demonstration area in the Partner Pavilion, as well as our website. And with that, we'll hand it over to Derrick.
So, okay, everybody. Just switching screens real quick because I need to see what I'm doing at the same time that I'm doing this. So.
I disagree.
Okay, so when you first log into our system, you're going to be provided with a management interface, and you'll notice that there's a nice login screen that's provided for you. So I'm going to log in with some basic test credentials. Now, before I move anywhere else forward, I'm going to show you 2 different servers. One of them is a sample server running on port 8180, which is what Tony showed in our last screen. You'll notice it's just a basic app. It has no idea who I am. It loads a bunch of data on the page, right? Nothing really too fancy about it. Now I'm going to load an instance of the exact same app loaded on a different server. There we go. And you'll notice it says access denied. Now, to give you some idea of what Tony was talking about, we didn't modify any code. I attached the Java agent to the server before I turned it on, and that's all I did. So from an idea of what that looks like, if you're running in Docker, it's 3 lines difference. So you import your original Docker image, you copy the jar into it, and the next time the server starts up, it adds a Java agent at runtime. If you're doing this without Docker, you just add the Java agent before the server starts, and you're good to go. No other work is required. Okay? Going back to my dashboard, once I'm logged into the system, You'll notice there's Users and Roles tab. This is pretty standard stuff for most identity management platforms. But what really matters is how we're going to change that application now that our agent's attached to it. So I'm going to go to System Integration first. And I'm going to add a server that I'm going to be monitoring, which is that server that we got an access denied on. So first of all, I'm just going to write secure sample as the identifier name. And I'm going to type in the domain name of that server. Now, the next time I refresh that page with the access denied, it's going to push records up to our system about that server. So I click here again, the page is reloaded, and now it knows that it's a JBoss server. If I click into it, it shows me all of the applications and web services that are currently deployed inside of that server instance that's running. Again, I didn't have to do any code modification. I just deployed a jar, and this is all provided to me, right? So now that I see all these things, I want to write a policy for myself to access the SOAP Vaden demo. So I'm going to click on the SOAP Vaden demo. I'm going to click on the servlet. Sorry, suck the page. I'm going to click on the servlet, which maps to all URLs underneath that application. You'll notice here exactly what I'm mapping it to. And I'm going to create an approval to access this. So I'm going to say anytime someone tries to do an HTTP GET request against this URL that has the username testadmin, I want them to be able to log into that app. So I'm going to save. And because this is a Vaden-based demo, it also requires posts, so I'm going to add that as well. Testadmin. Now, as soon as I refresh my policy cache, it's going to push a change out to those servers the next time they check in. And when I refresh the page I tried to access before, now we're going to have access to the app, and you'll notice it knows who I am. And it does notice that because we're hooking into J2E standards. There's a way to get the username as long as you're using a J2E standard. That's what it's doing. But you'll also notice one big difference between the original app and this one. The original app had a bunch of data on this graph. This one doesn't for some reason. Well, that's because there's web services that are behind this app that are currently being blocked. So not only are we blocking that front-end application, but any back-end data that that web application is trying to retrieve. So I'm going to go make a policy permission to access that as well. If I go back to my deployments, I know because I built the app that it uses the KML web service, so I'm going to open that. And there's a lot more servlets that are in here. One of them is called PyChart. If I move forward with this, and I hit the plus button, instead of seeing SOAP methods, or HTTP methods, you'll notice I'll see SOAP methods. All of these SOAP methods are the actual SOAP methods that are associated with that back-end SOAP web service. So this is real-time pulling these records up. So I'm just going to say, I'm going to let the guy see Firefox data. So I'm going to hit Next, pick it specifically for testadmin. Actually, you know what, just to switch it up, I'll switch it to making it anyone who's the administrative user. OK, set my policy cache. And we'll refresh the page real quick. And now, all of a sudden, I can start seeing data immediately show up on the page. This is instantaneous changes to code that you have running in production. I don't have to do any modification to inform any developers of these changes. I can do it on the go at any time. Now, this doesn't just apply to SOAP web services. This also applies to REST web services as well. So if I were to go to a REST demo service that I also have set up, again, access is denied because I haven't granted access to that yet. So I'm going to grant access to that as well first. Giving it get access just like before. I'll make it say any user can access the system. And I'll add post access as well, just as I did before, because it's a Vaden app. And if I go back, now I magically have access to this database, this application as well. And notice all of the maps on here are currently red. If I go to my sample server and look at the original app, oops, sorry, flipped two windows out by accident. There we go. Typically, it loads with an actual chart that shows different data endpoints. So you can actually see, where are hotspots on the map. On the version that's loaded currently in the secure website, none of that data is being presented because none of it's currently available. So I'm going to write a policy to quickly access that as well. And you'll notice while I'm doing all this, this all seems very, very, very fast. The truth behind this is if I had to do this by hand, it would probably take me weeks not only to add the security controls in place, but then I'd also have to modify any policies like this by hand. Notice I refreshed the page, though, and now the data is displayed. So all the backend REST web services, SOAP web services, we're controlling all of those, and any client that interacts with those things, we're controlling those as well. I'm going to take this a step further. Because our system is also built with auditing in mind, we audit everything that happens within your application. So if I go to my auditing mechanism, you'll notice there's a lot of audit logs here. I'm going to move this forward a little bit so we can get the most recent audit logs. And I'm going to type in SOAP because that was the last web service I think I tried to access. SOAP demo? Oh, Vaden demo. Sorry. There we go. And you'll notice before I tried to access SOAP Vaden demo, and originally I was denied, it's catching all of those. When I was finally granted read access to it, there was a couple other things that it showed I was being allowed access to that I didn't directly myself try and access. That includes this font set and this favicon icon, as well as some JavaScript. Anything your page tries to get, if it tries to grab an image on that website, we're going to see you trying to load that image and record and snapshot that information. This gives you all different kinds of information that you can introspect down to an individual method, file, or backend web service to be able to report back to your manager, hey, during this date and time, a certain user was accessing our system that shouldn't have been in here. Now, currently, I only showed us making policies about users and roles. We can also do them for date-time ranges. So if you have an employee who should only be accessing your system during normal business hours, we'll make sure they can't access it on the weekends. Or if it's geolocation, if you only want your customer or your employee to be accessing your system from Virginia, and all of a sudden they're starting to log in from China, obviously that's a problem. We're going to block them access to the system because their geolocation is wrong. That is SecurePaaS in a nutshell. I know it seems very simple and very oddly fast, but that is it. Do we have any questions? Yeah, go ahead.
Does it handle like whitelist testing?
I'm sorry?
Whitelist testing.
Yeah, you're talking about being able to monitor things like injection. That's the next step. We're going to be doing that in the next few weeks, working on SQL injection prevention, cross-site scripting as well. We think it's important that we have authentication and authorization controls in place, but obviously the biggest known attack vector for web applications is things like injection, right? So that's the next milestone on our marker is to hit that, and then we're moving on to cover .NET, PHP, Python. We want this to become the de facto platform for securing any application regardless of what language it's deployed in.
How do I prove it to my security guys without being able to run forward file?
Because I've changed it at runtime. You would run your application in a pre-prod environment. That would be the best way to do it. And then once in a pre-prod environment, you could use something like Selenium to run in a Selenium script against it to see if you could try and bomb the server by dropping a SQL script on it. Does that make sense? Saw somebody else's hand, sir?
Can I predefine the policies and templates where an application automatically loads and applies?
Yeah, you can definitely do that. If you can go into the system and instead of just doing it based off of system integration, which is a system we've already found, you can just go into our policy management. Oh, I'm sorry, hit the wrong button. And add your own policy by hand. So you can say, here's the server, this is what domain name it's going to be at. Once you create that, you can step through and add an individual resource type. So you can say it's an HTTP resource, it's a SOAP resource, it's a source code library. Put the file path or the code path, and then once you do that, you can step through and make any changes you want.
So full disclosure, I'm the OpenShift guy. So,
Yep.
He's the OpenShift guy. There's one of them, and he's here.
Yeah.
the next question I had is, so you're doing this on a single container. How do you correlate it with, there are multiple containers, multiple pods within the app? How does that handle rolling updates of and things of that nature?
Sure.
Environment, right? So
Yep.
that agent there, but what happens if that agent goes away and now it's got a new IP address because of an internal IP address that's represented?
Sure. So first of all, we can set up a server referenced by IP address, but that's not typically the way we do it. We do it by domain name. So we're kind of expecting that most people in the real world do require domain names to be associated with their containers, and if they roll and release new ones, they'll have a load balancer in front of it with other containers behind it, with DNS, right?
You got the router and you define
Yep.
the external route.
Yep.
But I'm saying you actually have gone into the app, right? You're on the container. I have 10 containers behind that domain name. So
Yep.
what I'm trying to understand is does it
So the agent you would attach to each running J2E container. So that way, anytime a new container instance gets spun up, like you would update your Docker image. So the next time you spin up a Docker image, it would have the agent already running in it. And every time you spin up a new container image, you would always have the agent attached to it. And that policy would apply to any agent with the same domain name, essentially. Make sense? So funny you ask that. Originally, we did use XACML years ago. We wrote a white paper along with many people who wrote white papers on why XACML is flawed in a lot of ways, both from a performance standpoint and from a reusability standpoint. One of the big things is you can write XACML policies that are very small that mean the same thing as a XACML policy that's extremely large. And so you can never guarantee performance that way. You can also run into policy conflicts in that if you write a policy that says, no, this user can't access this resource, and I write a policy that says, yes, this user can access this resource, which one wins, right? Which one takes priority? We removed all of those things by writing our own policy language. It's called EADS. We wrote a white paper about it when we initially built the system. It was released 3 years ago, I believe. Essentially, it's very performant because we've built it with performance in mind. You cannot write a not rule, so it's either you're allowed access or you're not based on you're explicitly denied from the beginning. Right, so implicitly denied. So when the system first loads, you're denied access to everything, and you slowly grant access to more things as time goes on.
So what that's done for us is it can do things like logical paradox elimination, right? So you can avoid things where you can write conflicting policies that ultimately could be applied against the same resource.
Yeah.
So by doing so, it's basically eliminated that possibility of policy crossover, because most XACML decisioning points are first best fit. Right, so when an XACML policy is being assessed, whatever XACML statement comes first and processes and is successfully processed first is the one that wins. So if you have a policy that says Tony can access the system and a policy that says Tony can't access the system, whichever one of those policies is read by the policy decision point first is the winner, which means it's kind of like a paradoxical
in a nutshell, no. We're
system.
using EADS though.
Yeah.
So, yes.
A couple of questions. So where would this fit in the development process? So if you don't change the code,
Mm-hmm.
would you do this before you do sort of your system testing,
Mhm.
like templates? Or
Sure.
would you do this after that? And then if that's the case, what do you do about like silent failures where things are sort of kind of working, but like for somebody you may be disengaged with necessarily mean that's happening?
It's an interesting question. First of all, I would say typically what we would recommend to people is that you would do all of your unit testing as you normally would against your system, making the understanding that whoever's the unit test is going through, that there's no security constraints controlled. So try not to build your app security in mind, not security in mind, but no authorization or authentication controls initially. And then when it gets to the point of pre-prod, that's when you would launch your agent attached to it, and that's when you would run tests for like integration tests to make sure your system continues to run once the agent's attached to it.
Things like load testing and things like that you'd want to do in as close to a production environment as possible. So you'd presumably start applying these types of things in pre-prod during load, kind of that load testing phase before rolling it into production.
Does that make sense?
Yeah, because it seems like you'd want to test, if you build
Sure.
a template of this, right? You'd want to at least validate and verify it.
Yeah, and you totally
absolutely.
could. The good thing about our system is that it's very lightweight, so it's rolled into a few Docker containers. We have one for Cupid, one for Postgres, one for an LDAP framework, and then one for all the services. So 4 containers, you deploy it anywhere you want, and you can run tests anywhere, right? Doug?
Because it's externalized, and now can actually have a separate testing phase.
Yes.
Just for security.
Yep.
Where accounting for is embedded.
Yep.
With accounting.
Exactly.
They're all about the
100%. And that's kind of another area where we see the value in this. Did I see another hand before? I thought I did from over here. No? Do we have any more questions? Yeah.
Do you log the policy updates for production auditing?
Yeah, you're talking about like when somebody changes a policy, do we audit log that? Yes, we do. I can show you that even. So let me take this out.
Yeah, so one of the interesting things about our auditing system is it doesn't just audit the applications, but it audits the system itself. So as changes are taking place within SecurePaaS, as well as within your applications, it actually can tell you who modified what policy or who created what policy, when and where, what those policies were applied to from a resource perspective. So you can actually backtrack through and see what the pedigree of your security policies and kind of how they came to be and who built them took place.
So you can see like, okay, test admin granted permit method. He created a permit method for this endpoint. And if I scroll this whole thing over, this is a little bit of a small screen based on the resolution up here. But if I scroll this whole thing over, you can actually see exactly what policy ID it is and then look up against it. Does that make sense? Yeah. Also, the policies right here, I'll be quite frank with you, this is just kind of a load of all policies, and you can search on it very easily. We're going to be correlating the audit logs together to say, like, oh, when a user accessed this app, this is all the stuff he was doing in that app at that given time. So that way you can kind of switch between which user was doing what and what he was doing with each session and things like that for easier correlation. Yeah? Yeah, so we currently have the backend is mostly SOAP, but we're switching it over to REST that you can integrate with. Honestly, I don't see a real great use case for it because all of the features are built in here, but if you had some custom use case and you were interested in modifying something, please come and talk to me after this, and I'll get you a business card and we can chit-chat. Cool? Yeah. So Akmal is an XML-based language. We encode it when we store it in our database, but you can store it in a flat file and read from there. And we have different readers. So technically, you could read it from FTP server, but just don't do that. So it depends on what you mean. So we do have an API for the policy access web service. We're very security aware of the problems that could be with opening up access to that. So we lock it down with 2A SSL to the dashboard itself. We could open it up if necessary, but the problem we see is if we leave the policy web service open, somebody could externally talk to the policy access web service and change a policy so they can get access to something. And we don't want that, obviously, right? So it's 2-way SSL right now, and if we needed to, we could open it up for particular use cases if you're storing it inside of your enclave.
Yeah, it's kind of like a double-edged sword, if I understand what your question is, right? Which is, we'd love to be able to notify the system to dynamically create a policy when something gets populated, but that in turn also creates a vulnerability in the sense that somebody could try to forge that request and then create or inject a policy that was not intended to be there.
And there's two different ways you could lock that down. You could put a firewall rule up that just says if you're not on localhost or if you're not inside of my local subnet, you can't access this port to get access to the REST web service. That would be an easy way to fix that. And then you could then open up the REST interface and use it locally just for testing purposes. I'm assuming that's more or less what you're talking about is deploy an app with Maven or something and have Maven kickstart a job with Jenkins to build the policy. Yeah. Sure. If you'd like, I'd like to have a conversation with you after this, and if it makes sense, we can even do that to help OpenShift integrate with it better, if that makes sense. So, yeah. Do we have any other questions? Oh. So that depends, right? It depends on your company. Some people have a team that's specifically built for writing policies. Some people, the company's so small that, when it really boils down to it, the person who's most liable for the company's assets is their security officer. So sometimes they have an IAM or a security manager that's meant for that role. It's going to be writing policies. Sometimes that can cause complications because they don't always know everything about the application they're writing policies for. But that's why we're also introspecting in your application to kind of provide information regarding this is what this app is, this is what methods it provides, this is what users are trying to access it, to try and give a policy writer who has no development background some kind of window into what it is they're writing a policy for, besides actually having to work with their team.
A lot of times the security team and the development team are two different teams.
Yeah.
and they try to work together, but they speak different languages. And so hopefully, a tool like SecurePaaS would help cinch up that communication and capability gap, kind of like we were talking about at the very beginning of the presentation.
You had a question?
Yeah, I'm curious. You got that jar wrapper that kind of wraps around and containerizes the actual application. How do you verify the integrity of that jar wrapper?
So you're talking about the agent before we deploy it?
Mm-hmm.
Of course. Yeah, of course. So the jars, we use secure code signing, which means at runtime we're checking to see if if the hash key matches to see if it's the same as when it was deployed. We also currently obfuscate it in hopes that it would be far harder using a couple different things like name obfuscation and whatnot to make it far harder to break it down and kind of decompile it. But essentially at runtime, what our library is doing is we're modifying any instance of JAX-RS, JAX-WS, servlets, and the clients that are associated with that.
Mm-hmm.
So for the most part, we're more modifying your stuff. And the only thing they could really do is if they somehow broke our jar, they could prevent it from modifying your stuff, which a simple test after deployment would verify that, because all of the modification happens at launch. When all of your code's being deployed is when we're changing it. Make sense? Yeah, so yes and no. We're right now building a mechanism for guest access. So not everybody has an application portal that a user is always going to integrate with. Application is one of them. Another one would be, you might have a home page to your website, essentially, where you want anonymous users to come in. So we're building into our system right now a guest access functionality. So when you have an application talking to each other with no user involved, it would be a guest-to-guest type methodology, and we would verify which app was talking to which app. Okay. If you got a particular use case, I'd love to talk to you after this. I'll give you my business card, and we can set something up. Make sense? Anybody else?
All right.
Well, thank everybody. Thank you all for coming.
Thanks very much for your time.
Gave a lot of interest.